the last video, you learned the meaning of dy dx, but the variables are not always y and x, and we need to spend some time to make sure we respect the variables in our problems. This will be especially helpful in the future when you solve related rates problems. Now, let's step aside for a moment and look at this problem. If you've just been introduced to implicit differentiation in class, then you probably recently learned how to find derivatives using the product rule. Now, a lot of us can just do it in our head, but for the purposes of understanding implicit differentiation, we can assign each of those sections a simpler variable. So let's call the first factor u and the second factor v. Now we know that to take the derivative using the product rule, we have to know the derivatives of the individual factors. So if I say that u is x to the fourth, then the derivative of u with respect to x is 4x cubed. Many of you might be tempted to say that the derivative of u is just 1. But that's not the case, because u is a cover-up letter that actually stands for x to the fourth. So the derivative of u with respect to x is actually 4x cubed. Doing the same thing for v, which is sine of x. The derivative of v with respect to x is cosine of x. So to use the product rule to find the derivative of this product, we take u and multiply by the derivative of v with respect to x, and then add the reverse expression, where we take v and multiply by the derivative of u with respect to x. And so u was x to the fourth, and dv dx is cosine of x, plus, and then v was sine of x, and du dx is 4x cubed. Now, many of you could have gotten this answer a few minutes ago, because this product rule is pretty easy to do in your head. But the reason I did this long way is because in the moment when you're taking the derivative of v or u, it might be tempting to say that the derivative with respect to x of u could be 1. Because we've seen many times that the derivative of x with respect to x is 1. But be careful, because this equals 1 only because the change in x divided by the change in x, that's the same quantity on the top and bottom. So this actually equals 1. But over here, I'm not so sure, because what we're looking at is how much does u change compared to how much x changes. And that is not necessarily 1. It could be 1 in some very special circumstances, but in general, this is not true. So we have to be careful. When you take the derivative of u with respect to x, it's not 1. It's du dx. And that is one of the most common mistakes that people make when they are taking derivatives implicitly, which we'll talk in great detail after we get the basics down. For this problem, I'm not going to simplify it anymore. I could, but that's how we get the answer using the product rule, and that's fine for now. If it's not immediately obvious to you what this has to do with implicit differentiation, please don't worry. I promise you'll understand by the end of the next few videos. Just to recap the point we were just trying to make. The derivative of a variable other than the one that you're differentiating with respect to, which is the independent variable. And by the way, with respect to, we usually abbreviate WRT. The variable you're differentiating with respect to is called the independent variable, and that one usually shows up after the d in the denominator. The derivative of some variable with respect to an independent variable, we write that as d variable over d independent. So in our case before, it was du dx. That's what it was before, just to be clear, to make sure we got that idea completely. So the derivative with respect to x of x, we can write that as dx dx, and that's the same quantity on the top and the bottom, so the ratio should be 1. But when I'm doing that with y, the derivative with respect to x of y is the change in y over the change in x. And I don't have a way of simplifying that anymore at the moment. So we call that dy dx. It's not 1. Now here in light blue, the derivative is now with respect to y. I'm changing the variables just to show you how to handle different situations. This may not be what you see in your problems, but it's okay. We need to understand how to navigate the information that's given here. So this is saying the ratio of the change in x to the change in y. Those are not the same, so I can't say that the ratio is 1. In this case, the derivative of x with respect to y is called dx dy. And then the derivative of y with respect to y is how much y changes divided by how much y changes, which is the same on the top and bottom, and so this one is 1. So you can only say that the derivative of a variable is 1 if you are differentiating with respect to that same variable. Now let's look at an example that has some operations done to the variable. We're taking the derivative of x cubed with respect to x. Now, since the last operation that happened here is a power, we're going to use the power rule to take the derivative. And the power 3 is being applied to the quantity x. So in order to take the derivative, we use the power rule, which says bring the power down, leave the argument alone, so still x, but decrease the power by 1. So this will be 3 minus 1, which is 2. But if you remember the chain rule, we're also saying, but don't forget to multiply by the derivative of the inside. And by the inside, we mean the thing that was being raised to the power originally. The derivative of x with respect to x is dx dx, but this is 1, so we don't write it. So we just have 3x squared. Of course you knew that answer a whole minute ago. But the point is that we've been using the chain rule the whole time. The quantity that was being raised to the third power is x, and if we remember to multiply by the derivative of that argument, the derivative of x with respect to x is 1. We've been doing it the whole time. We just haven't been writing it because it doesn't result in anything different. But take a look at the example on the bottom. It's the same format of expression. We're taking the derivative with respect to x, but now it's y cubed. Instinctively, many people just say that the derivative of y cubed is 3y squared, and they stop there. But you have to remember to multiply by the derivative of the inside. The thing that was being cubed is y. And if you remember what we did before in that other complicated problem with the u and the v, remember that y is just a cover-up for some messy thing in terms of x. So you can pretend that y was something like cosine of 5x or something. We don't know what y actually is, but if the problem said find the derivative of cosine of 5x all cubed, you probably wouldn't forget to do the chain rule part. So 3 cosine of 5x now squared. Chances are, because this inside is messy, you wouldn't have forgotten to multiply by the derivative of cosine of 5x, which is negative sine of 5x times 5. But the truth is that we don't know what y is in terms of x. We just know it is something involving x, but we don't know what it is. So instead of all this, This part that we multiplied right here is the derivative of what we were calling y. So this right here is dy dx. This whole bit that we did right here, this was just pretend. We don't know what y actually is. But what we learn from this is that we can't forget to multiply by the derivative of what y is. So we're missing here a dy dx. Chances are your teacher in class told you whenever you're taking the derivative of something with y, just put dy dx at the end. Which is correct, but it's more valuable if you understand why it goes there. You multiply by dy dx because you're using the chain rule to reach inside here and multiply by the derivative of the nested function, or the function that is on the inside of the composition. Let's find the derivative of a few more expressions that tend to trip people up. So the derivative with respect to x of xy, we have to remember that xy means x times y. X and y are being multiplied, so we have to use the product rule to take the derivative. So we can leave x alone and multiply by the derivative of y with respect to x. If I write it out, the derivative with respect to x of y, and then we add, and this time we have y times the derivative with respect to x of x. You don't have to take super long steps to do this. I'm just showing you in detail what's going on. So we have x times the derivative of y with respect to x is dy dx. And the derivative of x with respect to x is 1. So this part right here is 1, and the y stays. So can you see why somebody might erroneously think that the derivative of x times y with respect to x is x times 1 plus 1 times y? Most of that is okay, but the derivative of y with respect to x, this one, is not 1. But this right here is a very common mistake. That students make, so keep that in mind so you don't make it yourself. So the correct answer here is this one. Let's do another problem. The first thing to notice is that the independent variable is x. It tells us so right here. Now, the expression we're taking the derivative of has other variables. It has y's and it has t's. So we should be paying attention that when we take the derivative of either of those variables with respect to x, that derivative is not 1. So let's be careful. We can start by rewriting the expression because the square root, we're going to need to treat it as a 1/2 power. And since the last operation that happened there is the exponent 1/2, we're going to use the power rule to start taking the derivative. So we bring the 1/2 down, we leave the inside the same, and then we subtract 1 from the old power. So 1/2 minus 1, which is negative 1/2. But we have to remember to multiply by the derivative with respect to x of the inside, which is y plus 2t. So the first part, nothing changes. But the derivative with respect to x of y is dy dx. And the derivative of t with respect to x is dt dx. And it's being multiplied by 2. So it's 2 times dt dx. And that whole quantity is being multiplied by the first factor. Let me interject here and say that what we've been doing so far is not implicit differentiation. We are simply learning how to take derivatives of expressions that have variables that might throw us off in the middle of a larger problem. Here we're finding the derivative of x cubed times t to the 5th. but it's with respect to t. The last operation that holds this expression together is multiplication, so we'll use the product rule to take the derivative. We'll leave x cubed just as it was and multiply by the derivative of t to the fifth. The derivative of t to the fifth with respect to t is 5t to the fourth times dt dt, which is 1. We don't have to write that, but it is there. And then plus, this time we'll leave t to the fifth as it was, and now multiply by the derivative of x cubed, which is 3x squared. But we have to remember to multiply by the derivative of x with respect to t, which is dx dt. Usually we try to simplify as much as possible, but for right now, I'm going to leave it as it is. Now let's take the derivative of another product, x cubed times the square root of y, noticing that the independent variable is y this time. So the part we have to be extra careful with is the first piece, the one that has x. The square root of y is not in a great form for us to use, so let's take a moment to rewrite this expression as the derivative with respect to y of x cubed times y to the 1/2. Using the product rule, we'll leave x cubed untouched and take the derivative of the second piece, so 1/2 y to the negative 1/2 times the derivative of y with respect to y, which is 1, plus, and now this time we'll take the derivative of x cubed, which is 3x squared, times the derivative of x with respect to y, which is not 1, and then leave the y to the 1/2 as it was. Let's do one last example, taking the derivative with respect to x of the quotient, y over x. To take the derivative of a quotient, we use the quotient rule. And if you don't remember what that is, or maybe you haven't heard this little mnemonic, we usually say low d high minus high d low over low low. That's just a little thing that kind of helps you remember how to put it together. So low means the denominator. So we have x. D high is the derivative of the top. So we're going to multiply the denominator by the derivative of the top. The top is y, but we're taking the derivative with respect to x. So the derivative of y is dy dx. Continuing this little mnemonic, it has a minus. And then high d low. So high is the top, so just y. D low is the derivative of the bottom. So the derivative of x with respect to x is 1. And then over means divide the whole thing by. Low low means take the denominator and square it. So we have x and we're squaring it. Again, I won't simplify this anymore. What you learned in this video was how to take derivatives of expressions that have different variables, paying respect to a certain variable that is independent. Once you know how to take the derivatives of little pieces, then implicit differentiation becomes much easier. We'll learn how to perform implicit differentiation in the next video. Stay tuned. I hope you enjoyed this video. See you next time.